Hi everyone. So happy to have you all here for this session where we are going to learn about large language models from scratch, and we'll also be building our own AI assistant by the end of this session. So I am Deepthi Balasubramanian. I am a Microsoft Gold Student Ambassador. I'm also an AWS AI and ML scholar, and I'm presently interning as a software engineer at Honeywell. With me we have Lirish. Over to you for introduction.
Hello guys, very good evening. Myself Lirish Aravind. I'm a Beta Microsoft Learning Ambassador. I'm an upcoming Master's Data Science student at TMU. Over to Deepti.
Thank you for the introduction. So, in this session from voice to notes, we are going to practically work on our first language, large language models. And by the end of this session, as we discussed, we are going to build our own AI powered assistant. Sounds exciting? Can we get some reactions? We really want this session to be interactive, guys. So feel free to communicate if you're able to understand, if you like the concept, or if there is some question that's coming up at any point. Great. So let's move ahead. Firstly, we want to start by introducing our tech community. It is called the Accessible AI Hub. So I'm one of the co-founders in the community, and what we actually aim at is that we want to make AI education and AI practical skills accessible for everyone, be it a student, be it a working professional, or anyone who is higher up in the ladder. So we want to make AI inclusive, accessible, and exciting for all of you. So if you're interested in being part of a community, you can scan the QR, join our LinkedIn, follow us on Instagram, and also on YouTube. So we'll be sharing the link to our website where we have the recording to all our previous sessions, which starts from the basics of AI, what is a prompt, how to create one, all from scratch, and all of them have hands-on sessions as well. So if you're interested, I'll just pause here for a couple of seconds for you to maybe scan and be part of the team. Moving ahead, what are the prerequisites for this event? There are no prerequisite or experience required, and this session is designed to be 100% beginner friendly. So if you know what a large language model is, or how AI actually works or interacted with Copilot or ChatGPT, you're good to go. So the agenda for this session will include what large language models are, how they are trained, and what is their work. And finally, we'll be seeing how we can create our own LLM. Ready to proceed? That's great. What is a large language model? A large language model, or LLM, in short, so what it is really is that it is an AI trained model to understand and generate human language. So it can answer questions, it can summarize books, or even write code, depending on whatever we are asking it to do. So you can think of it like a super intelligent autocomplete. So whatever you're trying to get done, if you're able to provide some instructions, it will be able to do it for you along with proper reasoning. Next slide. So let us look at what a transformer actually is. So behind all LLMs is a neural network architecture. So it is called transformers. So what it will do is that from whatever input we are providing in the form of a sentence or a natural language in English or any other language that we are providing, it will use something called an attention mechanism. So based on this attention mechanism, it will understand what we are trying to say. So we'll be seeing how this actually happens in a few slides later. So transformer architecture, what it does is that it will process words in parallel, not one by one like all the previous models used to do. So this is done to make it faster and better in understanding text which can be longer. Some of the advantages of transformer can be that they are flexible. So whatever you're inputting, you're asking for a poem or any questions in any domain, like whether from engineering, arts, or any of it, or even if you're asking to detect sentiment, which is the emotion of a sentence, it can be made to do it by just feeding some training data. Now let us understand what general purpose model will do. When you consider any contextual understanding, so what it does is that when you provide an entire sentence, the model will first process each word and try to relate by uh, using some parameters. So if you provide a sentence like is there a bank near the place that I'm going. So in this case, the bank can mean the one where it deals with finance. But if I mention river bank, it means completely different, right? So the context is understood by words which are near and part of the sentence. So based on whatever conclusion the LLM is able to come to, it will be able to give us a more relevant answer. Sounds good? So as we saw, this is the example, like based on the context, it will be able to give us a more closely expected answer. Now let us see how LLMs are actually trained. So as we are speaking, LLM stands for large language models, and of course the data set for this will also be larger, right? So it will involve uh, quite some process which can begin from collecting data, choosing our own architecture, training it, then fine tuning it and optimizing it. And this process has to be done quite repeatedly until a desired accuracy is achieved. Next slide, please. How dataset is collected and how the pre-processing is done. So if you have followed our community, we recently released a blog on why a lot of AI models actually fail. We have so many models out there, but not all of them are to the standard, right? So one of the main things is to keep the data concise, uh, but not narrow, and at the same time the data should be of a good quality. So cleaning the data is the first step, which is removing unnecessary things, breaking it into smaller tokens, converting it into a format that our model can understand. So mostly we'll be creating a vector so that it is able to understand and process it as and when the need comes. So if you are interested, maybe we'll share the link to that blog, which is under a 2-minute read in a few minutes, but let us complete the section as well. Next one, after pre-processing the data, is the type of architecture that we are selecting. So different models has different goals. So if you take GPT models, they mostly process with textual data, right? But if you take models like DALI, they process images. So every model has a different goal. So based on the requirements and whatever we are expecting, we have to choose the architecture accordingly and start the pre-training. What is pre-training? So pre-training, how you can consider it, like when we were all learning a language, we had to understand the grammar and everything behind it, right? So the structure of the sentence, how the grammar works and all of that. So when the large language model is learning, it will do all of these by its own. So what it does is that it will predict missing or the next word that we can expect. And this is done over and over again and again with the billions of examples. So as you practice more and more, you're getting better at something, right? So similarly, the large language model also gets better with uh, practice. Sounds clear? Okay. So moving ahead, what you are seeing is next is fine tuning. So once pre-training is completed, what has to be done is the model has to specialize in something. So I mean, till grade 12, we were all studying the same curriculum, but when it came to bachelor's degree or something, we specialize in a particular thing, right? So like that, a model will also need to specialize in something. So when the training becomes that domain specific, the model will be more acting more smartly in that specific domain. So just like we spoke previously, something can be speech synthesis or text generation or image processing, all of that. So the model has to be qualified enough to take care of the task in hand. Next, we'll look at optimization technique. So when we do training for the first time, we can't guarantee that it will be like perfect. So we have to keep adjusting the model's internal weight, some of the parameters to reduce any errors. And some of the techniques that we will be using here is loss function, back propagation, and understanding the learning rate.
But don't use audio button.
Next slide. So next one is training infrastructure. So this step needs massive computing power because large language models are trained using GPUs or TPUs and not on CPU because of the size and the other aspects of it, and this is spread across multiple servers. So they are basically not trained from a laptop. You can imagine an entire room of data centers where these types of training take place to minimize time and also make it more effective. But now let us look at some of the challenges that are associated with training these LLMs. As we discussed, when we need a lot of infrastructure, the cost associated with it is going to be so much. It can be expensive and not always environmentally friendly. So when we are using these models, we have to be mindful of the importance and use it accordingly. And after training is completed, we evaluate. I think you'll have to move to the next slide. Okay, once training is completed, you have to continuously evaluate the model and compress it, deploy it, repeat the cycle so that it is uh, updated always, is fast and useful in real application. So that is how the entire cycle of LLM training and processing works. But let us now understand how large language models actually work. Over to Leerish. Thanks, everyone.
Yes, guys. So, hi, welcome again to the session. So, as DT discussed, what's an LLM and how do we train one? Now we're going to see how does an LLM actually work. LLMs use transformer architecture to process and generate human language. The process actually consists of three core steps. First one is we have LLM should understand the input. Second one is it should process the input. And the last one is generating the output. So we will discuss each and every step in detail. So the first, here comes the input or the encoding part. This is the very first step where we feed the data to the LLM. The LLM here process it where the input is transformed into numerical representations that the model can understand. As we know, a model or anything in general of computer science in computer science, it can't directly understand the input which we give, that is the language which we speak, can be English, Tamil, Hindi, or whatever it is. It has to convert into numbers basically. This is what happens here. First, what we'll do is the input text is split into smaller chunks called tokens. These are nothing but words or subwords. So, if you give a sentence like there's a car, it is broken down into smaller words. So, these are the tokens which are then converted into embeddings, which are nothing but the vectors representing the meaning of tokens in high dimensional space. This is actually quite complex, but let me break it to you. what happens is, if we consider a sentence, like I said, the words are actually broken down into smaller words. Like there is a car means it consists of three words, right? So the three words, yeah, pardon. Okay. So they are actually broken down into three words. There is a car. So four words. I'm sorry. So these are actually given assigned to numbers, which are nothing but these tokens. So these are converted further into embeddings, which are nothing but the vectors. So after which the tokens are passed through an embedding layer that assigns a dense vector to each token, capturing its semantic meaning. So what happens is these tokens, the numbers are again passed into the second layer, which has a dense number of vectors. It is the step where it will understand its meaning. Later, the embeddings are used as the input for the next layers of the transformer model, where they will be processed to capture the relationship between the tokens and input. So what happens first is we give a sentence to the LLM. The LLM breaks the sentence into words. The words are assigned into numbers and they are passed into the next level. The next level, these are assigned to what? This is nothing but the embedding layer or the vector layer, where each token is assigned to a vector. It is the place where it will understand the meaning. So what happens next is the embeddings are the embeddings, that is the output of the previous layer, is used as an input here, which acts this is a place where the relationships between each tokens are analyzed. So it will first understand its meaning and then relate with the other fellow tokens. So this is the first part, the encoding. The second one is attention mechanism. As DT discussed, you guys might be familiar about attention mechanism. So here is the detailed content of it. Once the input is encoded, that is, it has understood its meaning and it has related it with it has found its meaning. So the second one is the attention mechanism, which comes into play, which helps the model understand the relationship between the words in the sentence. So this is actually the level 2 process. It will further understand the relationship between the words. So what happens here is the first one is it uses the self-attention mechanism. This is the most important feature of a transformer. Whenever you consider a transformer, you can see a self-attention mechanism there. It allows the model to weigh the importance of each token in the relation to others. So here, for example, here's a sentence. We can use that. The cat sat on the mat. The model uses the attention to link cat and sat as they related in context, even though they might be separated by other words. So this is the place where actual understanding of the sentence takes place. So each token's embedding is transformed into three vectors: query, key, and value. These vectors are used to compute attention scores and determine how much focus one token should have on another. So what happens here is it will understand the meaning of the sentence, then it will assign importance, then it will split into query key value, then it will determine how much focus it should give when compared to the others. So the last step here is contextual understanding, which helps a model to capture both local and long-range dependencies in the text, enabling it to understand nuanced meanings, idiomatic expressions, and sentence structures. So, the first, for example, this step is actually an additional part, but nowadays there's also a core part of an attention mechanism. So if we give a idiom or a sentence which has deep context, the LLM has to further break down the sentence and understand each of them. So that is what happens here. So all these are explained in a very basic level, and so no need to worry. No need to worry about the jargons used here. I'm explaining everything in the simple terms. So the last step is output, decoding. First, encoding, it will take the sentence which we give, break down into tokens, embedded it, assign vectors, understand its meaning, relate with other words, assigns importance, and the last step is decoding. This is the final step where the model generates the output based on the input it has processed. So here we use autoregressive generations. In many cases such as GPT, the model generates output token by token. After processing the input through the encoder and attention layers, the model predicts the token in the sequence based on the previous ones. This is done repeatedly until the model generates a complete output. So it will first understand the sentence and the output is generated token by token. So it is actually a repeated process and takes place until the job is done. The next step is model generates a probability distribution over the possible next tokens and the token with highest probability is chosen. So it will actually generate a number of tokens. For example, for the given sentence, it generates for 10 to 15 tokens. For example, it will assign probability value and the highest value is chosen. The final output is the decoded tokens are then combined to form the final output text, which could be a sentence, a paragraph, sequence of text that is coherent and contextually appropriate. So what happens here is in decoding part, the based upon the tokens received and analyzed, the LLM will generate the output token by token. It will keep on generating until it generates a complete output. So after generating tokens, it assigns a probability value, and amongst all the probability value, the highest one is chosen. And the chosen tokens are then combined to form a output text, which can either be a sentence, a paragraph, or a sequence of text, which is contextually appropriate. So this is how an LLM works. This is the three main fundamental processes involved. So if you guys have any doubt, you can ask, or we can use the Q&A in the last part of this event. So efficient use. How can you efficiently use an LLM? So we actually communicate with LLM through prompting. So if a prompt is good, the output will be good, and vice versa. So to maximize the effectiveness of LLM, one should focus on prompt engineering and feedback refinement. You should give, your prompt should be very strong and you have to provide a relevant context, and you should also analyze the feedback which LLM returns. We have to provide sufficient background and we need to guide the LLM on the format or the style, like uh, specify the style, like it should be formal, it's for XYZ job and etc. We have to specify each and everything clearly. And the most common mistakes which everyone does is will actually bulk prompt, right? So for example, a junior developer is working on a project and he is completely giving the prompt as a single paragraph. In this case, the prompt will be a failure and the LLM will still try to understand what is being said, but the output is always inaccurate. So if you are given a set of tasks, LLM is also similar to us, right? So we have to give it point by point or break them into simpler tasks and make it understand so that it gives a very good output, which helps in satisfying our needs. So yes, so here's the part where I'll be showing you how to build a Power App or AI powered Power App without coding at all. So let me just share my screen again. Just wait for some time. Just a minute, guys. I'm just opening Power Apps platform. So I hope you can see my screen. Can I get a thumbs up or a reaction? Everything is good? Yeah, cool. No, it's open. Yeah. So for this hands-on, I will be using Power Apps to create a no-code app. So this is actually Microsoft Power Apps platform. So you don't need any coding knowledge to create an app. This is actually the final ads which we're going to do. So I'll also run and show it for you. And just a minute, I'll just get the text. I don't know why my net is so bad today. Please excuse me, guys. Okay, so we'll just show how the app works. For example, I'm just giving this prompt a few minutes. So it just understands it and it gives the important points of the input which I've given. So let me just give a preview through what the Power Platform is. So this is actually Microsoft Power Apps platform. You don't require any prior coding knowledge to create an application here. This simply it has a drag and drop architecture. So for example, we'll just show some demo here. So I want to add a button here. It's actually, I can just simply drag and drop wherever I want, and I can edit the properties over here. I don't have to code at all. It saves a lot of time as a developer, but this still has some demerits. It's actually problem specific. If a use case is so small and it is within the organization, people always prefer Power Apps over traditional apps. But if the use case is something different, like we have a huge volume of crowd to handle and we need to do some more customized app, we choose traditional development. So this is actually Power Platform, and you can choose the canvas. Now I've developed for mobile, and let me just build one and show. This hands-on actually consists of two parts. First, I will be showing you how to create an app using Power Apps. Later, I will show what is Power Automate and how you can automate your flows. So this is actually the place where you can create app. You can either start with a data like
ഹലോ ഹലോ
yes,
എന്താ
അവിടെ പുറത്തുനിന്ന് ചായ കുടിച്ചിട്ട് വന്നോ? Yeah. So you can either start with a data source. Data as in I'm telling Excel, you can even use some Azure blob storages or anything or your traditional database. And or else you can use start with a page design. It has a specific templates which you can readily use. Or else you can just start one with a blank canvas. So I'm choosing a mobile app now. Okay. So this is actually the blank template here, which you can simply drag and drop whatever you want. I'm going to add a text input here. This is the place where you enter your notes, and I'll just add a heading here. And I'm just drag and dropping a button here, and it says summarize. No. And this is the place where you have your output summary. And another part to clear the output once it's done. This is a basic app. I'm not you styling the apps as it's up to you. You can do whatever you want. You can choose. You can style it however you want. All is available here. For example, if you want the background, you can change it here. You can insert an image, fill in it whatever color you want. Change the button backgrounds. For example, I'm changing the color into whatever you want. So for now, I'm just having this. So this is the basic app which you're going to use. Now let me go to Power Automate and show how we are going to embed AI powers here. So Power Automate is another platform which comes under Microsoft ecosystem. So this is a place where you can automate simple things, complex ones also you can automate. For now, I'm just showing a simple automation. So here, I'll just explain the existing flow. All these boxes are known as triggers. Triggers are functions which gets activated when an event occurs. So for example, what this Power Apps trigger does is whenever I fire a Power App in that platform, it will trigger this flow. And once this flow gets activated, it calls this one and this goes until the end is reached. So this just activates the Power App when I open the app there. And this is a place where I initialize the nodes which I'm going to give in. So these are nothing, this is of type string and has a value ask in Power Apps. This is actually user customizable. You can give whatever you want. And the second place is AI Builder. So this is actually a important trigger or the one which summarizes your notes. So I will explain you how to create this. For now, just understand the triggers used in this flow. And the last one is we'll fetch the generated key phrases and store it in another variable. So this is and again one variable which takes the input from the key phrase trigger and stores here. And from this, we are going to respond to the Power Apps. So this is how you can, this is how a Power Automate works. And you can save here. Now it's getting saved. If you have any errors, it will pop up here. Okay. Now our flow is ready to go. We don't have any errors. So I'll just show you how to make another Power Automate from scratch. you can head to the create icon here and click on instant flow. For this session, I'm just going to create an AI summary. Okay. And the trigger is this thing. So this is the trigger which gets activated whenever you open a Power App. So provided you have to connect this to a Power App. So the next step is I need to add a variable, right? Initialize variable. Yeah. Here, I'll just give a simple convention. My notes, and this is of type string and from Power App. Okay. After which, so what I'm doing is I'm just creating a flow which gets activated when a Power App is created. Provided I link this to the Power App, and I'm just taking a variable which fetches the text from the Power App to this Power Automate platform. Now I'm going to create an AI Builder prompt. Okay, so this is the place where we extract the key phrases. So I'm just choosing English, and the text is the dynamic one. If you create the initialize variable correctly, you will see it here. So I'll just create it here. That's it. Now this will do the job. It will summarize the input which you give and give the key phrases as the output. So this is actually powered by OpenAI Codex LLM, I guess. This also comes under Microsoft's Copilot thing. And after summarizing, I'm storing it in another variable, which comes under, yeah, here. The input is a dynamic one. This thing, key phrase. This is just a minute. Now it's already there. So I just have to bring it up with the AI compose. That's it. And now this is the place where it should respond back to the Power App. So we have our Power Automate ready and then just save it. So for some reason this input isn't working. So let me compare it with my previous one. I have to give this as an input. This is a place where I'm joining the contents of the previous one and storing it in the array. This is actually optional parameter here. This is a formula which has to be inserted there, not the simple one. So this is the error here. Okay, so this I've entered and this is the flow here. So how we have to connect with Power App is head to your Power App and here you can see three dots here and head to Power Automate. You can add a flow here. Meeting notes is added here and that's it. Now this is added to our Power App and let me just include a sample text which I have stored somewhere. Just a minute. Sure. No. Okay. So this is how it works. I'll just enter a sample text. Oh, I forgot to remove this button. That's it, guys. The Power Automate is triggered our input and we have the summarized output here. This is how you can build a Power App without coding and all. So just a minute. And that's it, guys. We have reached the end of the session.